Oops, that didn't quite work, did it? Oops, there we go. There we go. Okay. So, thank you, everyone. And I'm here today to talk about what we're doing with the Medical Devices Working Group. Now, this group has been an active, basically active pretty much since the project started. However, we're starting to get to that point where we don't really have a good use cases, sort of like automotive in that sense. And we've sort of done all that we can do with the current use case we've been working on. But so I'll give you a bit of an overview of what we've been up to over the past few years and where things are right now so that you can sort of decide what's going on and hopefully leverage some of the work we've done. So basically, OpenAPS was actually brought up at the very first ELISA workshop. And when we were trying to sort of storming effectively to try to figure out, okay, what can we actually tackle that's out in the open? And since it was an open source project, and whereas most of the medical stuff is under NDA, it gave us a chance to actually start to look at systems and to start looking at the system theoretic process analysis methodology. That seemed to be where we've actually been able to do a bit of decomposition and actually requirements generation and so forth from that. And so we started on that. We started looking a little bit at the medical ventilators and some of the risks around that. And then we went back to looking at what 62304 is asking for. And so we have some guidance there in terms of what can be done from an open source project perspective versus what the standards are looking at that we put up on our website in the GitHub. And then we've been pretty much steadily working our way through the methodologies of STPA for the last few years. So the 62304 work is we compared the STP analysis we've been doing to it and the software of unknown provenance route. And we basically have a report sitting there in GitHub that people can go and access and work from. And if people have questions, by all means, still start to post into the repo or onto the mailing list, and people will engage. The STPA approach, though, has been sort of the heart of what we've been working on, which is looking at the things as a system and then trying to understand how Linux's role is in that full system. In some senses, it was almost sort of the precursor to the systems working group, because I know that we were starting to, how do we actually look at a system? And then it sort of inspired some of the work to go on and made it very clear we had to start looking at systems. So the system working group formed. But what we did is we took this OpenAPS, which is an artificial pancreas system, which is a loop of a glucose monitor and a insulin pump. And it has a Raspberry Pi between them that basically calculates the information that's coming out of the glucose monitor and then helps people using it as hobbyists to make better, to basically manage their insulin pump and insulin capability so that they have a more stable line in terms of their reaction to food and so forth. So the project, none of us actually were insulin users or anything else, but we did think it was an interesting project, and we were lucky enough that we were able to do that. But it gave us a good open view that we could actually take that iterative approach and basically work through diagrams and then work through the level 1, level 2, level 3 analysis to an extent and take it down to the Linux level to see sort of where we can start to make forward progress. So the community itself was open, and there's a lot of really good talks out there about why. But as you can see, the insulin pump is connected, is basically communicates with the Raspberry Pi, which is also communicating with a continuous glucose monitor. And the information from there is what helps the insulin pump be a bit more real-time reactive to the person's body and to get the information and take it from that way. And there's a lot of, since this came out, there was a lot of pushback from medical manufacturers about it initially, but the FDA did come out and said some of the open source solutions, including this one, were improving the quality for people. And things seem to have quieted down there. There's also now more commercial offerings out there for those who wish to go with an established as opposed to a hobbyist perspective. And so in that sense, it has shifted the things to make some of these technologies more available faster than they might have otherwise been. This is our level 1 diagram that we basically developed and have iterated on several times and refined several times based on more information. And basically, you're looking at various actions and controls and understanding, okay, what has to happen with an action, what are the responses coming back to the operators, so forth. And so this is the open APS system, and it's basically a human operator, which we've had to eventually realize, no, it could not be the same person as the body, because it could be, a parent working with a child or something like that. So there's a distinction in roles that sort of emerged out from this. And by analyzing with the methodologies in STPA, we were able to sort of tease this out and to figure out realistically what are the key actions and so forth. And then we drilled down on the open APS and got to the fact we've got the Raspberry Pi OS, the toolkit, and then the algorithm, which are the key elements. And realistically, the Raspberry Pi is where we actually have Linux sitting underneath the covers. So Linux is sitting underneath a lot of covers as the operating system. And so it isn't per se participating in the algorithm, it's a substrate that these devices are running on. And so looking at that problem and trying to understand what were the requirements in Linux and what were the key parts of Linux that were engaged is part of what we were focusing on through the years. So we actually took it down to the Linux level and then started getting into the side of things of, okay, well, what are the actual static system views that we need to care about? What are the dynamic system views? And then worked a lot with Shua and Shafali to actually start to get some traces of as these workloads are happening, and the devices are running, what is actually being triggered out of Linux and what part should we be paying attention to. And so we did some initial work on the methodology there and actually got some contributions on a tracing methodology included upstream in the kernel. So we have to say thank you right off the bat to the Open APS community for providing the traces, since none of us who are working on this actually, were using it with the glucose monitor and insulin pump. But this methodology did let us discover the subsystems in use. And it did give us a way of starting to look at how do we do event tracing with the kernel. And so extracting the system calls, doing the mappings and so forth. So there was a white paper that was generated and the methodology was documented for others to take and learn from here. And we used a lot of open source tooling already sort of available there. So this is kind of what we've been sort of working at. And then that was mostly till pretty much end of 2023, early 2024. And then so last year, mostly what we've been working on is just polishing up what we've had. We basically updated the STPA results in our GitHub repository. One of the things that was an interesting learning from this is the fact that the STPA methodology will generate a lot of duplicate. If you're doing it properly, it duplicates duplicate and redundant requirements. And so one of the cool things that Milan did is he started using some of the AI works to actually try to find and identify common requirements. And so we could reduce the set down and play around with doing that type of work. So our L1 and our L2 requirements have been scrubbed and reviewed. And Nicole basically worked with us pretty closely to make sure all our requirements were well-formed requirements. And we were articulating, and this has all come out in a reverse engineering style from the STP analysis rather than from looking at the code. So this is a different way of looking at a system. We also did some work. We had done a lot of our work in a spreadsheet, and we created a tool. Milan created the tool to basically take and convert the STP analysis spreadsheet into a YAML so that it could be machine readable and processed further with other tooling. And so that's kind of where we've got it right now at this point in time. So the tools are checked in and so is the current L1 and L2 analysis. That's all up in GitHub. So if people are interested in looking and seeing what was generated, it is there and is welcome to be used. We did hope to be able to start to generate out an SBOM with this and start to be able to look at that part of it. Unfortunately, the Open APS and the Raspberry Pi system was not amenable to moving into Yocto, and we couldn't, and so our Shefali basically gave it a good try, and we were looking for a mentor, but we couldn't find a mentor in the Yocto community to help us. So we did a reach out, but when we couldn't get a mentor, we said, okay, we're gonna put this on the shelf then. And there's other applications that we can generate SBOMs from. So from the systems perspective, I think there's work still to be done there. But we basically decided, okay, OpenAPS isn't going to let us get there easily. So we'll look at other things. And then throughout the year, we were looking to see if we could find any other use cases. It was sort of an ad hoc type of, okay, if someone brings us something or we find something interesting, maybe we can start a discussion. But we really haven't gotten any use cases identified. So this is kind of bringing us to today. We're at this point in time just finishing polishing up a white paper that summarizes all the work we were doing for the last few years. And our analysis of the requirements has pretty much, finished off, and we've basically been committing all our results to GitHub. And so there's a white paper that is being worked on. And so we will hope to publish it sometime in the next, we're working on it as time permits, along with other things. So hopefully mid-year, we should probably get this out there and have it polished and be able to say done on the box for this one. And that's kind of where we are. For next year, obviously, this finishes the white paper. But at this point, we don't really have anything to talk about in the groups, so we're just basically going to suspend the groups until a new use case is identified. If people have ideas on some new use cases and are able to start working on them with us, we'll certainly keep the mailing list active, and then we can start to, reconsider doing meetings and so forth. But as part of the natural life cycle of these things, I think we're sort of at a point where it seems like, okay, we'll put it on the shelf for a while, and we'll just basically be going forward from that. And we will be calling a few ad hoc meetings, so watch the mailing list if you're interested in participating. And with that, I guess I just want to say thank you to the folks that have been here for working on this for the last, 4 or 5 years, which is Milan Lahami, Shefali Sharma, Nicole Papler, Jeffro, and then Shua. And so we wouldn't have gotten any of the results without all their efforts. So I think with that, that's pretty much all I really had to say today. Any questions? Okay.
There's one in the
Yep.
chat which says if I can help introduce you to biomedical and micro devices, biomems at the University of BC, British Columbia as some use cases. Please let me know. They are focused on US medical device security.
Yeah.
Yeah, this would be
Thanks,
good.
Gary. If you think that they want, like I say, we're a community to help collaborate with and focusing on the safety side more than the security side per se. But if they've got open examples they want to start discussing in the open, we'd love to engage. So thank you. Anyone else have thoughts? Okay. Well, and I think we could probably stop recording, Min, and